AI and cybersecurity, protecting against emerging threats. AI is key to detecting emerging cyber threats. Artificial intelligence, AI, has become crucial for identifying and thwarting cyber threats as they develop quickly and become more sophisticated. Much more quickly than humans, AI systems can analyze enormous amounts of data to find novel patterns that indicate cyber attacks. AI-based cybersecurity systems continuously monitor networks and user activities to build a baseline of typical behavior. Then, they can look for anomalies that might point to an attack. For instance, AI systems can detect potentially dangerous behavior if a user suddenly downloads abnormally large volumes of data or checks in from a strange location. AI can identify novel attack strategies that have never been used before by spotting links across enormous datasets. This skill is essential as fraudsters try to quickly exploit new vulnerabilities. AI also aids in detecting zero-day attacks, which are brand new vulnerabilities that have not yet been fixed. AI powers predictive analytics to estimate the likelihood of specific sorts of assaults in addition to detection. When resources are prioritized, cybersecurity teams can bolster defenses against the most pressing threats. AI also automates defenses against typical assaults, freeing up security teams to concentrate on the most advanced threats. Overall, AI promises to revolutionize cybersecurity by utilizing data and algorithms to detect new threats and support information security. When integrated with human judgment and oversight, AI poses new risks, such as adversarial assaults intended to trick AI systems. Yet it is more necessary for avoiding today's cyber threats. The speed and scope of contemporary attacks may make progress in the cyber weapons race impossible without AI. Machine learning algorithms can identify malware and phishing attempts. AI and machine learning are essential technologies for cybersecurity as cyber threats advance. Machine learning algorithms can detect malware and phishing attempts by identifying trends and abnormalities. Large datasets of good and bad code are used to train machine learning algorithms. After learning the traits of each type, the algorithms can analyze new files or emails to decide whether they are likely to be dangerous. Malware detection. To identify malware such as viruses, worms, and spyware, machine learning models examine attributes such as file structure, metadata, and code instructions. Traditional signature-based techniques are much less effective at detecting variants of established malware families than algorithms. Phishing detection. Machine learning analyzes emails and web pages to identify phishing efforts. When determining if a piece of content is authentic, or if an effort to steal data or install malware, the algorithms consider elements including words, formatting, sender information, links, and images. As phishing emails become more complex and targeted, machine learning is essential. Machine learning dramatically enhances malware and phishing detection, albeit still having some shortcomings. The algorithms become more intelligent as they are exposed to more data over time. The use of AI in cybersecurity must continue evolving to keep up with new dangers, as cybercriminals also employ machine learning to generate increasingly sophisticated threats. Generally speaking, machine learning is an effective technology that, when used in conjunction with human expertise, aids in the development of vital defenses against cyber attacks. Artificial intelligence helps with vulnerability management and patching. AI and machine learning are helping security teams keep up with the volume of vulnerabilities. AI systems can analyze huge amounts of data to identify vulnerabilities, prioritize risks, and determine optimal patching strategies. AI improves vulnerability discovery. Massive amounts of data from vulnerability databases, vendor advisories, and open-source platforms are combed through by AI using sophisticated data analysis techniques, including natural language processing. To more quickly and accurately identify potential risks, AI can spot patterns and connections that humans might overlook. Security teams are freed up to concentrate on the most important risks thanks to AI's reduced number of false positives they must investigate. AI prioritizes vulnerabilities by risk level. The level of danger presented by each vulnerability varies. Artificial intelligence, AI, evaluates vulnerabilities based on factors such as the Common Vulnerability Scoring System, CVSS score, exploitability, malware campaigns that actively target the vulnerability, and assets that the issue affects. Then AI ranks vulnerabilities so security teams can focus on the greatest threats first. Prioritization guarantees that security teams effectively use their time and resources. AI optimizes patching schedules. Patching vulnerabilities requires striking a balance. To prevent disruptions, patches must be applied promptly while simultaneously being thoroughly evaluated. AI can analyze enormous amounts of data to identify the best patching schedules based on risk levels, dependencies, and operational implications. Artificial intelligence may find strategies to minimize business disruptions while accelerating high-priority patching times. AI does patching in a data-driven manner that increases security and productivity. Artificial intelligence improves identity and access management. AI and machine learning enhance identity and access management (IAM) systems. IAM solutions verify users' identities and control their access to systems, applications, and data. AI helps improve IAM in several ways. Detecting anomalous behavior. AI systems can analyze huge amounts of data to identify users' typical behavior patterns and spot anomalies that could be signs of compromised accounts or insider threats. AI can identify anomalous activities for further inquiry by keeping track of metrics like login locations, access requests, and resource consumption. Adaptive authentication. AI analyzes user profiles, login locations, and access behaviors to assess risk and choose the best authentication techniques. A transactions or request for access is risked determines how much authentication is required, and AI makes this possible. A straightforward password might be sufficient for low-risk access. Multi-factor authentication, such as biometrics, may be necessary for high-risk access. Automating provisioning and deprovisioning. AI can aid in streamlining the procedures for granting access to new users and removing it from people who leave the company or change jobs. AI systems can automatically provision and deprovision access to systems and data by examining job duties, access requirements, and termination checklists. This lessens the administrative burden and guarantees that access is granted and canceled promptly and legally. Continuous monitoring. IAM systems can utilize machine learning to continuously monitor user access and entitlements to find instances of unauthorized access, inactive accounts, and improper segregation of roles. AI tools can examine entitlement and role data to identify and fix problems, like people with excessive access or contradictory roles. Organizations can ensure compliance and least privilege by continuously monitoring. IAM systems will continue to be improved by AI and machine learning to increase threat detection, expedite procedures, and enable adaptive risk-based access control. By utilizing AI, organizations may lower risk, improve compliance, and improve access governance. Overall, AI will play a key role in assisting IAM systems to offer thorough protection against new cyber threats. AI enhances network monitoring and threat detection. In some significant areas, AI and machine learning are improving network monitoring and threat detection. AI systems can analyze massive amounts of data, can analyze massive amounts of data to find patterns and anomalies that point to potential risks. Artificial intelligence, AI, can detect indications of DDoS attacks, malware infections, unauthorized access, and other problems by applying machine learning algorithms to network data, logs, and events. AI finds connections and insights that would be difficult for humans to find independently. What do you think of our video? Let me know in the comment section below. Before you go, please hit the like button and subscribe to my channel. Thanks for watching.